Alrighty, let's go ahead and go over the content from 2.17. The start thinking part says that you have these two different equations. What I'm looking for you to do is I want you to solve by graphing. And after you solve by graphing, you'll be able to figure out what the solution is, and then you're going to solve by elimination. The reason why I gave this task to the students was that A, I wanted to see if they could convert into slope-intercept form. B, I wanted to make sure that they could graph. C, I wanted to make sure that they knew how to solve by graphing. And then lastly, there was something a little funky with the solution, and I wanted them to be able to identify when it was this funky type of solution when they're solving by elimination or substitution. So as you can see here, we have gotten both of the equations into slope-intercept form. You get y equals negative 2/3 x minus 2, and you also get y equals negative 2/3 x plus 3. So when you graph these, you find out that you end up having parallel lines. And since you have parallel lines, they are not going to intersect. And the intersection is always going to be your solution. So this means that there is no solution. So it's pretty obvious when you're looking at this to see that there's no solution. Now, when we solve by elimination, I'm curious what part of solving by elimination is going to show you that there is no solution. So as you can see here, we had to multiply the top equation by 2, and you get 4x plus 6y equals 18, and then you have negative 4x minus 6y equals 12. And when you add these together to solve by elimination, something weird happens. When you eliminate your x's, the x's go away, but also the y's go away. So both the x's and the y's go away, and you end up with this equation, which is 0 equals 30. 0 equals 30 is obviously a false equation. So we make the connection that on the left-hand side, when we solved by graphing, it was no solution. And on the right-hand side, when we solved by elimination, the variables went away and you ended up with a false equation. So that brought us to this right here. And basically what it is when you are solving by elimination or substitution, if both of the variables are eliminated and you end up with a false equation, then it is going to be no solution. If you did the same exact thing and it was a line on top of itself when you graphed, meaning infinitely many solutions, it wouldn't be the variables go away and it's a false equation. The variables would go away and it would be a true equation, like 0 equals 0 or 7 equals 7 or 5 equals 5, something that is true. That would tell you that there is infinitely many solutions. So what I had the students do then was I gave them an equation 3x plus 5y equals 10, and they had to figure out another equation that when you solved by elimination, you would end up with no solution or infinitely many solutions. What you needed to do is you needed to figure out another equation so that when you added or subtracted, both of the variables would be eliminated and you would end up with a false equation for no solution and a true equation for infinitely many solutions. So the one that I came up with is negative 3x minus 5y. That is going to, when you add that to the top equation, is going to eliminate the variables. And then when you have 10 plus 6, you would end up having 0 equals 16. That's a false equation, no variables. Therefore, it is no solution. The other one, if you did negative 3x minus 5y equals negative 10, when you solve this by adding them together, you end up getting 0 equals 0, which is true, meaning infinitely many solutions. Many students came up with many different possible equations. Now on here, the students were supposed to be looking at when there was one solution, meaning one intersection, when there were no intersections, so no solutions, and when there were infinitely many intersections, also known as infinitely many solutions. And they were supposed to try to figure out what was true about the slopes and the y-intercepts. Now, when you go over and you look at the slopes, for one solution, it was different slopes. For no solution, it was the same slope. And for infinitely many solutions, it was also the same slope. So that brought us to the y-intercept. You can see with infinitely many solutions, the y-intercept has to be the same. For no solutions, it's different y-intercepts. They can't be the same because they're going to be parallel, not on top of one another. And then lastly, in this case, the y-intercepts are different, but it's very easy to have two lines that intersect, and they also intersect at the y-axis, meaning their y-intercept would be the same. So in this case, it does not matter if the y-intercept is the same or different. So basically, the sum here, like the summary, is that if the slopes are different, you already know there's going to be only one solution. If the slopes are the same, then you have to look at the y-intercepts. If the y-intercepts are the same, then it's infinitely many. If the y-intercepts are different, then it is no solution. we had these problems right here. Now, the tricky part is you can only see your slope and your y-intercept if you get it in slope-intercept form. So in problem number 1, you can see easily the slope is 2, the y-intercept is 3. But on the second one, it's in standard form. You cannot see your y-intercept and you can't see your slope until you get it in y equals mx plus b form. So you can see the process of adding 4x to both sides and then dividing by 2. That allows you to see that the slopes for the two lines are going to be the same and the y-intercepts are different. If you imagine two lines that are the same steepness but go through the y-axis at different places, they are going to be parallel. No intersection, no solution. On the next one, after I distributed the 3 and got it in y equals mx plus b form, you ended up having a slope of -3 and a y-intercept of 2. And the other one also has a slope of -3 and a y-intercept of 2. So that one would be same slope, same y-intercept. It's just the same line. So that means they're on top of each other, infinitely many solutions. And then the next one, when you get the second one into slope-intercept form, you end up with a slope of 3/2 and a y-intercept of, let's see, 1. So you don't even have to look at the y-intercept since they have different slopes. The only answer is 1 solution. Now, on this situation here, I know it says Jerry starts 5 feet. It's supposed to say 5 miles. So Jerry starts 5 miles past the start line, is walking at 3 miles an hour. Karen starts at the start line, is also walking at 3 miles an hour. So you're supposed to write two equations. The equation would be d equals 3x, meaning how far they go after x hours, plus the 5 original miles. The next one would just be d equals 3x plus 0. Next, it says solve by substitution. So when you solve by substitution, you end up getting the variables disappearing and you get 5 equals 0. So that's weird. It seems like there's no solution. But if you actually think about the problem, if one person is walking 3 miles an hour, another person is walking 3 miles an hour, and one person is 5 miles in front, they will never end up at the same exact spot. One person is always going to be 5 miles ahead of the other person. And that is why this comes up saying no solution. There's no time when they're going to be at the same exact place. And that's it. So when we take a look at our homework, on the homework, you have one equation, y equals 3x minus 1. It gives you 3 other equations and says this is going to have one solution, no solutions, or infinitely many. So you need to get it into a form so that you can see the slope and the y-intercept. So that's what I did for each one of them. I got the top one became y equals 3x minus 6. The next one became y equals negative 3x minus 1. And the next one was y equals 3x minus 1. So when you are comparing the slopes and the y-intercept, that top one is going to end up having the same slope, different y-intercept, meaning they're parallel, and that's going to be no solution. The second one just has a different slope. I know 3 and -3 seem like they're really similar, but they're not. They're very different slopes. So that is going to, we don't even have to look at the y-intercept. It's just going to be one solution. And then the next one ends up with the same y-intercept and the same slopes. The lines are on top of one another, and that would be infinitely many. Now on number 2, it says given the following system, determine how many solutions there would be if the following things happened. So I decided to multiply by 2 just to figure out what the equations would look like. So as of right now, if I just solved, if I left everything as is, which is the answer to C, and I solved, you would get 0 equals 0, meaning true equation, no variables. That would be infinitely many solutions. Now going back up to A, it says if you only change the 3, if you're going to change the 3 to any other number, that is going to change the problem so that you no longer would be eliminating both the x's and the y's. You would only be eliminating the y's, and in that case, you're going to end up with one solution because you'll be able to solve for x. The x's don't get eliminated. If all you changed was the 5, then that means that you would be getting rid of the x's and y's, but the other side would no longer be equal. The left side and the right side would no longer be equal because you would, when you subtracted them, one side would be 0 and the other side would give you something other than 0. So that would be no solution. So once again, one solution, no solution, infinitely many solutions. The next one is solved by substitution. The reason I put this problem in is because I had some people who were struggling with solving by substitution. The easiest equation to get into y equals or x equals form is that one on the left. All you have to do is add 2x to both sides. So now you have y equals 2x plus 5, and you can substitute into the right one. When you do that, you just need to make sure that you're distributing the 4. When you distribute that 4, now you only have x's. You're able to solve. You get x equals 4. Sub it back in to either equation, and you get 13. So 4, 13 is the only point that would make both of them true. Same answer you'd get if you'd solve by elimination or by graphing. On this problem right here, this is slightly different. This one says that the person is starting 7 miles ahead and they are going 2.25 miles per hour. The other person is starting at the start line and they're going at 4 miles per hour. And it's wondering what the two equations are. So you get d equals 2.25h plus 7. The other one is d equals 4h. And then you're supposed to solve by substitution. When you solve by substitution, you end up getting h equals 4. Which just means at 4 hours, they will be at the same exact spot. How far will that be? Well, if you substitute 4 in, you find out it is going to be 16 miles. So distance is 16 miles. At 4 hours, they will both be at that same exact spot. The next one is one of those nickels and dimes problem. You have 5n plus 10d equals 130. Make sure you don't do 5n plus 10d equals 1.3 because then you're comparing cents and dollars. So it's either 0.05n plus 0.1d equals 1.3, or I recommend just doing it in cents. So 5n plus 10d equals 130, n plus d equals 19. That is the total number of nickels plus dimes equals 19. And then you would solve using elimination, and you end up getting an answer of 7 dimes, 12 nickels. And then I checked it. I actually got it wrong because I said D for both of them. And when I checked it, I realized I was supposed to get N for the second one. So that is that. On this last one, you're supposed to solve by elimination. I just wanted to give you a really hard problem. As you can see by my scribbling, I make mistakes as well. Negative 15 plus 14, I accidentally said was some other number other than just negative 1. So when you solve this, you end up getting negative 1 over negative 41 for y. And then remember, when you get these ugly fractions, a lot of times it's better just to start the problem over and just solve for the other variable, eliminate the variable you hadn't done before. So your answer is 29 over 41 and 1 over 41. All right, hopefully that all made sense. Thanks for watching.